lives.
Well, that went well. Now where was I? Oh yes, nanotechnology is the science of ultra-small particles. Particles so small, they're measured in nanometers. Billions of a meter. How small is a nanometer? Well, a sheet of paper is 150 nanometers thick. The nanoflake metal layer is offered to the conventionally printed trigger image, transferring it only in the image area where it bonds instantly. Since only the metal used in the image is consumed, there is zero waste, enabling nanometallography to cost half of conventional foil printing. It is fast and easy to use, simplifying the production of complex metallized graphics. And unlike foil, nanometallography is microwave compatible. Landa nanometallography can be used with virtually any printing process, whether mechanical or digital.
Nanometallography is a fabulous innovation. But I'll bet most of you never heard of it before you came to Drupa, and that certainly was not the reason that you came to this show. I'll bet that you came to Drupa to gain insights into the future of our industry. In particular, what technology will replace mechanical printing as society moves into the digital era. Will that be inkjet? Will it be nanography? And hey, what's the difference anyhow between inkjet and nanography? The fundamental difference between inkjet and nanography is with inkjet, there is ink-paper interaction. The wet ink contacts the paper. With nanography, there is no wet ink paper interaction. There's no effect on the paper ink behavior. You see, ordinary papers absorb ink. That means whether they're coated or uncoated, they all suck pigments into the body. The ink penetrates into the paper. Those pigments, rather than being on the surface where they could efficiently absorb light, get buried into the paper where they are wasted. The ink can even be seen through the back of lightweight paper stocks. And because wet ink also wicks along the paper fibers, the edges are not smooth, they are ragged. This inefficient use of ink means that you have to use a lot more ink to get acceptable densities, but a lot more ink means a lot more water penetrating into the paper. So much water, in fact, that at high speeds, it's very difficult to dry. So high-speed inkjet is limited to low area coverage documents, such as books, direct mail, transactional mailers, and the like. Moreover, because different papers have different absorptions, print quality is entirely substrate dependent. Every paper has a different quality. So, how does inkjet attempt to deal with this problem? Well, if you can't print on ordinary paper, you have to apply special coatings to the paper. These coatings limit the amount of penetration of the ink into the paper. Good. Thank you, good job. So, these special coatings not only are more expensive, they're not really what customers want. I mean, imagine putting yourself in the position, saying to your customer, hey, Mr. Customer, from now on you have to use only special papers. How will your customer react? Of course, because your customer wants you to produce their jobs on the papers they choose. Now, don't get me wrong. Inkjet is a wonderful technology. It's wonderful for home printers. It's wonderful for office printers, for certain commercial applications, for certain industrial applications. But if you want to replace offset printing, you need to be at high speed and at high quality and be able to print on any ordinary paper. Have a look.
The nanographic printing process begins with the ejection of billions of microscopic droplets of Landa nano ink colorants onto the special image conveyor blanket. Each row of ink injectors adds its own color of nano ink. Each droplet of nano ink lands at a precisely designated location, blending with other droplets to create the final colored ink image. As each droplet lands on the heated blanket, it begins to spread and lose its water, becoming thinner as it does so. When all of its water has been evaporated, the ink becomes an ultra-thin, dry, polymeric film. Let's look again. As the nano ink film spreads and dries, it becomes only 500 nanometers thick, the thinnest ink image of any printing process. The completed 4 to 8 color image is now ready to be transferred. Because of its unique properties, Landa nano ink images have the amazing ability to bond tenaciously to any paper or plastic without penetrating the substrate. Upon transfer, the nano ink film instantaneously bonds to the paper, forming a tough laminated layer, leaving no residual ink on the blanket. Nano ink images can be transferred to sheets or webs of any ordinary coated or uncoated paper without any kind of pre-treatment. Since nano ink images are already dry, they can be coated in line with conventional UV or water-based coatings, and printed goods can be immediately processed right out of the press, even in the most aggressive finishing equipment. And all of this with superb print quality at offset press speeds. Ensuring precise, reliable operation 24/7. Both the S10 and the S10P are capable of printing at a breathtaking speed of 13,000 B1 sheets per hour in straight load, while the S10P can deliver 6,500 double-sided B1 sheets per hour perfectly.
Aí está a Landa Nano, vamos ver que é o modelo maior dele. Maior que o 7.